So there's got to be some physical explanation for it, and our explanation or our interpretation is that the Arctic and the cryosphere in the Arctic is playing an important role. So starting with the spring and summertime snow cover changes, first, this is the ensemble mean. All the ensemble members are similar in snow cover change spring, snow cover change in summer, and this is fraction on the right. In the springtime, the big reductions are mainly in high latitudes and in high elevations, as shown here. But in the summertime, there's not a whole lot of snow remaining, but even in the present day climate by summer. But where you do see changes most pronounced is here in northern Siberia, and you get the largest reductions there. And that's of interest because that's also co-located with the ridging that maximizes there. And our interpretation is that earlier snowmelt in the springtime and summertime is leading to soil moisture reductions, as shown here. There's a good correspondence in northern Eurasia between the reduction in soil moisture peaking with the reduction in maximum snow cover. And by contrast, over the central U.S., where the drying and enhanced heating is most pronounced, there is a big soil reduction change, but it doesn't seem to be explained by a localized reduction in soil moisture. So we think that that's more of a response to the circulation changes rather than a driver, which may be happening more in the Arctic. The changes in snow cover, and I'm going to talk about sea ice cover, is not the only explanation either. It's also how much remains. So this is the actual remaining snow cover and sea ice concentration by late 21st century. First for snow cover on the left and sea ice on the right. And what you see is that there are two primary areas where you have remaining snow and ice cover, that being northeastern North America, around Greenland, as you would expect, but also the Canadian archipelago. So you see around Baffin Island and Ellesmere Island a considerable amount of snow cover remaining in summertime, even by the late 21st century. And similarly, this is also a region where you get maximum residual sea ice cover. And the reason for that is it's an area of sea ice convergence. And so this is to be expected, that this is the hardest sea ice to remove, even by late 21st century summertime. So both of these conditions, the existence of residual snow cover and sea ice, are important for explaining localized cooling. And we see that in this bottom figure, the change in summertime surface temperature. We do indeed see a reduction in warming in this area due to the residual snow and sea ice pack, and also the ocean influence. This is the heavily maritime area, high heat capacity, and so it's to be expected that that area would cool less than the adjacent land. And finally, the importance of this for our hypothesis is that if we compare this change in summertime surface warming on the left to the change in summertime heights that I already showed on the right, the area of troughing shown here corresponds well to the area of minimal surface heating on the left. And of course, correlation doesn't prove causation. Why couldn't the troughing happen for some other reason and produce the surface cooling? That's a possibility, but we think it's actually surface-driven for the reason that in this region of relative reduction in warming, this is an area of sea ice convergence, high heat capacity to the ocean, and the presence of an ice sheet, all of which, independent of any change in upper air patterns, would produce reduction in heating. So to wrap up, we find in this model a projected drying and heating of the interior U.S., which is associated with a hemispheric-wide pattern of ridging aloft. And this pattern is linked to snow cover loss and soil moisture depletion in middle and high latitudes, so it's not just local. The weaker warming and troughing aloft near Greenland and the Canadian archipelago due to residual sea ice cover appears to act to displace the ridging band southward over North America. And when it's in that position, it's in a very favorable region for enhanced drying and heating of the continental U.S., both in the mean and for extreme drought and heat wave conditions. Our follow-up analysis on this work is first, two parts in tandem, to isolate the role of Arctic warming in driving these circulation changes in this model to make sure it's really coming from the Arctic and not from, say, the tropics, and then to compare this response in other CMIP-5 models to see how consistent it is across other GCMs. Thank you.
Questions? Chuck again?
In a paper yesterday morning, it was pointed out CMIP-5 models have a very strong dry bias in summertime precipitation, which inability to model the nocturnal precipitation maximums that seem to occur in the U.S. Midwest. Have you looked at, in your data analysis, as to whether this additional drying you're seeing is occurring at nighttime, or is it mostly a daytime phenomenon that you're looking at?
Yeah, that's a good question. We have not looked at that level of detail yet. My understanding is that the nocturnal jet simulation is typically a problem in GCMs, and hopefully it's being improved upon by higher resolution. I know that there's a lot of work being done on that, but that's a good question, and I don't know whether any sort of summertime dry bias in the mean present-day climate is coming from daytime or nighttime. That's something we'll look at.
All right, there's a question over there.
Just a comment on that third bullet. You say it's due. Actually, you think it is. Okay, just to clarify. You haven't shown that it's due to it. The two papers ago, one of the really good things that was in that paper is that the very first step, there was a crude validation of the model on the historical period. And I don't see any of that here. And this gentleman in the front row just pointed out that this model is too dry. So wouldn't it be a good idea to first understand what the efficiencies of the model are in representing the current climate? Because this technique of just subtracting now to the future it's logically weak if the model if the historical runs in fact are not representing the current climate right now.
It's always a good idea to do that, and this is going in multiple phases here. Pardon?
I mean,
Well, this is not the final word on this paper,
you
and
haven't validated the things that you're looking at.
part of the analysis will include a multi-model analysis of the response and other models that will include any sort of biases. But generally, the signal from this 8.5 forcing is so strong that it typically overwhelms mean model biases, which are always going to exist. But I agree that it requires more analysis as well.
I think for the CCSM4 model, it's a community model. It has been validated, compared in many papers. So there are some research work on that aspect, but I guess in this particular talk, they were unable to mention those related research.
One thing they do know is the sea ice model in CCSM4 is much better than most models, but I have not looked in detail at the summertime precipitation conditions.
Okay, John?
Just on the first bullet, the usual explanation for the first bullet is, soil moisture evaporative feedback, which is amplifying, the response. Now, your emphasis is on these regional, connections, tropical or in your case, Arctic connections. But do you think at all of, it's more kind of canonical to think about the local feedbacks as being responsible rather than the remote ones?
Yeah, I think that as I showed in the earlier figure where I showed the reduction in soil moisture over the central U.S., I think that that's very likely acting as a positive feedback for enhancing the drying and the heating. Sorry?
A dominant positive feedback, and yours is perhaps a secondary one. Would be
Yeah, and one of the ways we're going to try to separate that is by doing these geoengineering experiments that we're doing where we try to suppress the amount of warming that we get in the Arctic, and that'll try to separate the Arctic forcing from the local feedbacks like you're describing.
All right, thank you very much.
Thanks.